Hello everyone, myself Dr. Ghodke Mangesh. I am here to discuss about antitubercular agents. So first we'll go through the definition of antitubercular agent. So in 1882, Robert Koch identifies the tubercular bacilli, that is Mycobacterium tuberculi. The first breakthrough in the antitubercular chemotherapy occurred in 1938 with the observation that sulfanilamide has weak bacteriostatic mode of action. So the Mycobacterium tuberculi look like this. The symptoms of tuberculosis are constant coughing, weight loss, fever, night sweating, and swelling in the neck region. So first we'll go through the classification of antitubercular agent. There are two types. The first type is first line agent. These drugs show high efficacy and low toxicity. For example, isoniazid, pyrazinamide, ethambutol, and antibiotics like rifampin, rifamycin, and vancomycin. The second line agents are the drugs which have low efficacy and high toxicity. When the resistance to first line agents occur, then and then only second line agents are given. For example, para-aminosalicylic acid, ethonamide, and antibiotics like streptomycin and cycloserine. And the third category is new drugs, having the examples ciprofloxacin, azithromycin, and ofloxacin. So first we'll go through the first line agent. The first example is isoniazid. This is the structure of isoniazid, having the common name isonicotinol hydrazide, or the IUPAC nomenclature is pyridine 4-carbohydrazide. Here the basic ring is pyridine. At the fourth position it is having CONH-NH2, that is carbohydrazide group. First we'll go through the ACR of isoniazid. The first point in this, the movement of carbohydrazide group to position second or third results in decrease in activity. Means CONH-NH2 group must be at the fourth position. The conversion of hydrazide group to other carbonyl group, example hydroxamic acid, results in decrease in activity. Means CONH-NH2 group is essential for the antituberculosis activity. If we change CONH-NH2 into the CONH-OH group, then activity will be decreases. The alkyl substitution to NH2 group, the last terminal NH2 group, produces various effects, like substitution by dialkyl group results in good activity and substitution by trialkyl group results in bad activity. This is the example. A number of hydrazone derivatives have been prepared by reacting with aldehyde or ketone group. Then it shows somewhat less and some similar activity as that of isoniazid, because after metabolism or hydrolysis reaction, they will again form the parent compound. A hydroxylamine or amide substitution decreases the activity. If the basic ring, that is pyridine ring, is replaced with furan, thiophene, benzene, pyrrole ring, then activity will be decreases. Mechanism of action of isoniazid is it mainly inhibits the synthesis of mycolic acid required for the mycobacterial cell wall. Means the mycobacterial cell wall, it will consist of mycolic acid, and isoniazid will inhibit the mycolic acid synthesis. Second example is pyrazinamide. This is the structure of pyrazinamide. The basic ring is pyrazine. On the second position it is having CONH2 group. So the IUPAC nomenclature is pyrazine 2-carboxamide. Then we'll go to the ACR. So almost all the structural modification results in decrease in the activity. Means if you change any group in the structure, it will decreases the antitubercular activity. Next, the substitution with NH2OH Cl CH group results in decrease in activity. If we add all these group on this nucleus, then it will result in decrease in the activity. The replacement of carboxamide group with acid ester or thioamide results in decrease in activity. Means CONH2 group is essential for the antitubercular activity. Now the basic ring, that is pyrazine ring, is replaced with any other ring system like furan, thiophene, benzene, pyrrole ring, then it will decreases the activity. Mode of action of the pyrazinamide, it is weakly tuberculocidal and active in acidic medium. It is highly active toward the intracellularly located Mycobacterium tuberculi. The mechanical action is not known, but it is resemble with the isoniazid, that it inhibits the synthesis of mycolic acid, which is required for the cell wall of the bacteria. Now the third example is ethambutol. This is the basic drug ethambutol. Centrally it is having 2 carbon. To that 2 carbon it is having the 2 amino group, and that amino group NH group having the 1 butanol, and that OH group it is at the transposition to each other. The basic nomenclature, IPC nomenclature is 2,2-diamine ethane dibutane 1-ol. The SAR of this ethambutol is when the distance between nitrogen atom altered by insertion of atom like carbon, nitrogen, oxygen, sulfur results in decrease in activity. Means only 2 carbon is required in between that 2 nitrogen for the antibacterial activity. The moving the OH group at second or third position results in decrease in activity or inactive compound. Means OH group it must be at the first position of butane. Replacement of alcoholic functional group with phenoxythioamino group results in decrease in the activity. Replacement of butanol group with other isopropyl functional group results in decrease in the activity. And the trans form of ethambutol is 16 times more active than the cis form. Means that both OH group they are on the opposite side of each other. Mode of action of ethambutol, it is active against dividing and growing mycobacteria. Its selective toxicity toward the mycobacteria appears to be related to the inhibition of the incorporation of mycolic acid into the cell wall of this organism. Means again the same mode of action as that of isoniazid pyrazinamide, it will inhibit the incorporation of mycolic acid so that cell wall formation does not take place. Thank you.